Everyone builds their first agent demo, watches it work beautifully, and assumes production will be just as smooth. Then real traffic hits, and suddenly your elegant framework is dropping requests, burning tokens, and timing out in ways the tutorial never warned you about. So which one actually holds up when you throw thousands of concurrent users at it? LangChain or CrewAI? Let's stress test both until something breaks. Start with what these tools actually are, because people conflate them constantly. LangChain is a general-purpose orchestration library. It gives you chains, tools, memory, retrievers, and callbacks, a toolkit for wiring language models into workflows however you want. CrewAI, on the other hand, is opinionated. It's built around the metaphor of a crew, agents with defined roles, tasks, and a process that coordinates them. LangChain hands you Lego bricks. CrewAI hands you a pre-assembled team and asks you to describe the job. That philosophical difference shows up hard the moment you scale. Under light load, both feel fine. The real divergence appears when you look at concurrency and state. LangChain's execution model is flexible, but that flexibility means you're responsible for managing async execution, connection pooling, and rate limits yourself. If you naively run synchronous chains inside a web server, you'll block threads and watch latency climb. CrewAI adds another layer. Its multi-agent coordination means one user request can spawn several sequential LLM calls as agents pass work between each other. That's powerful for complex reasoning. But under load, it multiplies your token spend and your latency per request in ways that catch teams completely off guard. Let's talk about a concrete scenario. Imagine a customer support system handling 500 simultaneous conversations. With LangChain, you can build a lean pipeline, one retrieval step, one generation step. And if you use the async interfaces and batch your embedding calls properly, it scales predictably. You control every hop. With CrewAI, that same request might route through a researcher agent, a writer agent, and a reviewer agent. Beautiful output, but you've just tripled your API calls and introduced coordination overhead. At 500 concurrent users, that's 1,500 LLM calls in flight, and your provider's rate limits become the ceiling that everything crashes into. So what actually breaks first? In most real-world tests, CrewAI hits the wall sooner, not because it's poorly built, but because its abstraction encourages more model calls per unit of work. When those calls stack up, you see cascading timeouts, retries piling on retries, and cost curves that spike vertically. LangChain tends to break later, but when it breaks on you. Memory leaks from unclosed sessions, exhausted connection pools, and silent failures in custom callback handlers that nobody wrote error handling for. One fails from design pressure, the other fails from developer negligence. The honest takeaway is that neither framework is inherently more production-ready. They fail differently. CrewAI's failure mode is predictable and structural, which paradoxically makes it easier to plan around. Cache aggressively, cap agent iterations, and set hard token budgets per task. LangChain's failure mode is emergent and sneaky, which means you need real observability, tracing, structured logging, and load testing before launch, not after your pager goes off at 3 in the morning. If your workload is high volume and latency sensitive, think chat at scale or real-time APIs. Lean toward LangChain with tightly controlled, minimal chains. If your workload is lower volume but reasoning heavy, where quality justifies multiple agent hops, CrewAI earns its overhead. The framework that breaks first is almost always the one you deployed without instrumenting. So before you pick a side, load test your actual use case, watch your token counts, and instrument everything. The winner isn't the framework, it's the team that measured before they shipped. If this saved you a production incident, subscribe, and I'll see you in the next one.